In this course, we will provide an in-depth overview of Dynamo, a visual programming plugin for Autodesk Revit. Dynamo is also available in a standalone version known as Dynamo Studio. We will look at the node system and interoperability workflows to integrate computational design capabilities into your building information model. We will start by introducing visual programming and data flow so we can see how Dynamo handles Revit automation. Then we will get into data types and how to work with code blocks to more efficiently drive Revit parameters. Lastly, we will look at expanding functionality through custom Python scripting as well as packaging our own scripts for future simplified use. Dynamo is an open source visual programming tool that is enabled to work cross-platform with various industry tools to maximize workflow. In many of these examples, we will be working between Dynamo and Revit to exhibit how the tool provides capabilities for sophisticated data manipulation and geometric control that is often not possible using conventional interfaces. Combining the fluidity of visual programming and scripting with a tightly integrated BIM model, Dynamo exposes a fundamentally new way of working with geometric information within Revit. Let's go ahead and launch Revit to access the Dynamo plugin. The plugin can be accessed in the Add-ins menu. In most cases, we would go ahead and resize our windows to work uniformly side by side, or if you have a multi-monitor setup, it may be helpful to drag the windows onto their own displays. Dynamo is comprised of a series of menus, drop-downs, and search fields. Let's discuss the basic interface features. The File tab contains New, Open, and Save features, as well as a screenshot option and STL export, commonly used for 3D printing. The Edit tab contains Copy, Paste, Undo, Redo, as well as a note creation option which will come in handy breaking down your workflow. The Alignment option is also very useful in maintaining a neatly organized workspace. The View tab gives us access to our basic navigation control that can also be used in a variation of ways. There are also different options for modifying the visualization of the workspace, such as toggling between curve or polyline wire connections, as well as an option for toggling the 3D model background preview. The Packages tab contains a series of options for creating, storing, and finding package scripts, which we will discuss later in this tutorial series. The Settings tab contains the number precision and render quality. Default settings should be acceptable for most applications. Finally, the Help tab offers a series of resources for Dynamo-related content. Jumping down a bit, you can see we have a tab system by default labeled Home. You can only have one active tab running at a time. However, you can access custom nodes and packages in other tabs. To begin programming, nodes are placed in the workspace and then connected together with wires. The node library located on the left side of your screen is a browser for picking and searching nodes. The node library is broken down into categories that expand out in a directory type format. You can also use the search option located at the top of the library by either searching for the name or phrase associated with the action you wish to carry out. By clicking the node, it is automatically added to the workspace. You will notice a blue border surrounds the node. This indicates that the node is currently selected. You can zoom to the selected node by clicking the dash box icon on the top right, or delete the node by pressing the delete key, or selecting the delete option in the edit drop-down menu. There are a series of Dynamo sample files that are associated with the content shown in these tutorials that can be accessed at dynamobim.org/learn. Click on the link called Datasets for the video tutorials to download the files. Open up the first file by navigating to File, Open, and select the first file titled Getting Situated with Dynamo. You'll be prompted with an option to save your current file before proceeding. We can see the workspace contains a series of elements including nodes and notes. This is commonly referred to as a definition. We can see the watch node contains the coordinates of a Cartesian point. This represents the output of the previous two nodes. By default, Dynamo operates in a live mode, which means data is updating in real time as changes are made and will update downstream. This feature can be modified when working with heavier computational scripts by clicking the automatic button located in the bottom left corner and changing to a manual operation. The Watch 3D node can also be used to visualize what is taking place. To navigate the Watch 3D node, press and hold the middle mouse button to pan, the right mouse button to orbit, and the middle mouse scroll to zoom. These controls stay true for navigating the 3D viewport in the main workspace as well. At the bottom right corner, we have the option to change our view controls from the script to the model. On the top right, there are more controls for a secondary method to navigate the space. To save the model, navigate to File, Save. To create a new version of the model, use the Save As option. Dynamo files use a .dyn extension, not to be confused with Revit's .rvt format. Exiting Dynamo will return you back to your Revit document.